Intelligence, back with me again, Ajiga Utama Putrada. I am your lecturer for parallel and distributed systems. This is our 10th meeting about parallel programming design. This is the last video. In the last video, we will discuss about an example. So we have discussed that there are 6 steps in designing a parallel program, and now we have a program and we want to create a parallel program from this program, and we have to answer the following questions that we have learned before. So this is a Python code. The Python code is as this. There is a list. A list is just like an array in other codes. So A is an array or a list with the member 10, 20, 30, 40, 50, 60, 70, and 80. And there's a variable called B, which is equal to 0. And there is a loop here for I in A to B equals B plus I. So this will continue until all of the members of A have been executed. So the questions are: one, is it able to be parallelized? And secondly, how is it partitioned? And three, is there any communications? And then four, is there any data dependencies? And five, is synchronization needed? And lastly, is there any load balancing? So what do we do? First, we um, decompose the problem, or in other words, we understand the code. So here we have an array which has 8 members, 10, 20, 30, 40, 50, 60, 70, and 80, and the operation is here, it loops. It loops all the members in A, all of them, 10, 20, 30, and so on, and all of them are added into B here. So B first is 0, so here first it's 0 equals 0 plus I, which is the first member is 10, so 0 plus 0 plus 10, so B is now 10, and then 10 is added to the next member, so 10 plus 20 and so on, 20, it becomes 30. So basically the code means yes, and the final result will be in B, so it will be B equals 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 plus 80. And now we want to ask, is this able to be parallelized? So this is the operation, and now we want to answer the question. So the step 2 is answering the question: is it able to be parallelized? And answering that is, we just need to see the problem and see 10 plus 20 plus 30 and plus 4. Is this Fibonacci? No, it's not Fibonacci. So if we have, for example, 4 processes operate this operation at the same time? And the answer is yes. So the first question, is it able to be parallelized? And the answer is yes. How would the problem be parallelized? And the answer for this is SPMD or MPMD. So for example, we have 4 cores. Of course, we will divide this into 4 different cores. So 10 plus 20 will be in one core, and 30 plus 40 will be in another, and 50 plus 60 will be in another, and lastly 70 plus 80 will be in. So uh, the data is divided, and like we said earlier, that if the data is divided, then it is SPMD. So the second question, SPMD. Yes, and SPMD. Are communications needed? The communications, there are several types. There is point-to-point and there is collective. Here, the operation will be 10 plus 20, which is 30, 30 plus 40, which is 70, and 50 plus 60, which is 110, and 70 plus 80, which is 150. And then all of them needs to be added again. so it will be 30 plus 70 plus 110 plus 115. So this is a collective communication, and if you remember which type of collective communication, it is reduce. So all of them are added in a separate core, and all of them are gathered in one core with a type of operation. And are there any data dependency like we discussed earlier? If there is communication, there is data dependency. So yes. And is there synchronization needed? Yes, because when it is collected in the same point, there needs to be a synchronization, which is block receive. So yes, and the answer is block receive. And will load balancing be a concern? I don't think so, because all of the cores have balanced load. Each core is calculating the same amount of numbers. So will load balancing be a concern? The answer is no. So that is the end of our example. If you need another example, you can answer the questions. So that is the end of our last video. In this last video, we have successfully discussed about an example, and in this meeting, we have discussed about parallel design. I'll meet you in the next meeting.